Evening. How are we? It's been a couple of weeks since I've been out in the workshop. Not a massive amount. A fair amount of work's happened, but not a massive amount. Because as I said in my last video, I'm coming into my busy time of my normal day job, so it's kind of workshop work goes by the by, unfortunately. So we're going to cover a few things actually making something tonight, or not a few things, we're going to cover something tonight in the workshop on the other side. But some feedback that I've had recently, one bit that it resonated a little bit with me, and that was to look at each part as its own entity as opposed to looking at a complete engine. That's kind of, I've taken that on board to a certain extent with the rear drag box for the engine. I don't know if you've seen my post yesterday, I think it was, of the rear drag box kind of ready for TIG welding together. That's gone now. My mate has been and picked it up today for me, so he's going to get on with that. But I'm looking at that as getting that complete before moving on to the next bit. But while that's away at welding, I thought, well, I may as well do something, get people up to date video wise. One thing you might have seen when the engine was on display, or if you haven't seen it when it was on display, I had some front footplate supports on the engine. That's one of them there. Now that is actually completely wrong. That's my bad on that one. And it's wrong in terms of how many holes are in the top of it. Not how many holes are in the top of it, but how wide that top piece is. It should look like that. It should have a double row of holes in it, because the footplate that sits above it, one piece actually comes and makes the slope down to the lower front foot plating, and the other piece is for the foot plating that comes over the top of the cylinders. It's got a double row of holes in it because there's a foot plate join down the middle, so one bolts one way and the other bolts for the other side. But what also sits on top of that, on top of the foot plating, is the atomizers, which are, if anyone knows a class 2, the atomizers are a very visible thing on this engine. So if it's a visible thing, it's got to be there. So once I did some delving and looking at the works drawings, I picked that out. I picked out that double bolt hole, and I was like, okay, I need to rectify this cock up. And that was one of the laser cut parts I had on show, but it was in a packet. I haven't soldered that yet, and that leads me into a bit of tonight. But something, it raised its ugly head again, and me talking about laser cutting is a good way to feed into that. Is laser cutting cheating in model engineering? Now, some would say, yeah, it's cheating because essentially you're having parts cut, sticking them together, and then you've got the completed part. So yes, it is, but it's also taking advantage of modern technology. Now, as I harped on many moons ago when I had the frames cut, if anyone's seen a video, and I might put a link on for this video, of an old LMS engine being built in 1930 whatever, of a Duchess, no, I don't think it's a Duchess, Coronation class or whatever it is, 6207. Someone will obviously comment and say what engine that is. All I know, it's an LMS engine, Coronation class I think it is. 6207, and it's called a Study in Steel. I'll put a link on anyway. Now, if you go watch that video, and you'll see the frames being cut. Now, the frames turn up to that works as a sheet of steel. Then they are cut with, I think they call it oxy coal gas cutters on video, and they're using a template one side which has already been shaped out, and it cuts out the other frame. And they do them in pairs obviously, for obvious reasons. And then it's gone on to drilling and everything like that. Now, where is the difference to, because that was good technology when you think about it back in those days, 1930s. So where's the difference to me doing this now? Having my frames, I've drawn it, sent it off to be cut. Now, apart from me not having a laser cutter in my workshop, where is the difference? So, am I cheating? No, all I'm doing is, this is a traditional model engineer's view of it. I should have bought a sheet of steel, marked it all out by hand, chain drilled, hacksawed, filed, and until my bloody fingers have gone purple with numbness, to get one frame, or one side of the frames, and then do it all again to do the second one. Brilliant. I don't want to be sat for the next bloody 40 years building an engine. As you already know, I don't get that much time in the workshop as it is in the summertime. So when I get out here, I want to get as much progress done on an engine build as I can, so I can then get on to the next engine build, and so on and so forth. That is the end goal, is to build an engine, have it running and enjoy it in my lifetime. If I had loads of time, which back in the day, in the 60s, 50s, 70s or whatever, people had more time. We weren't obsessed with social media, we weren't obsessed with other things, and life didn't get in the way. They seem to have more time than we do, because we waste a lot of time doing videos or whatever. But anyway, the point is, it's not cheating, because I'm getting on with the job. I want to get something done. My traditional things that I still need to do, I still need to hacksaw, I still need to file, I still need to use a lathe, I still need to use a milling machine, all those things. So how is it cheating? It's not cheating at all. It's using technology that we've got today to get something done more efficiently and quicker. Because if it's cheating, that means that me using a powered bandsaw to cut steel is cheating, and I should go at it with a hacksaw and sweat my nuts off doing it. No, I want to cut through a piece of 1-inch bar steel squarely and fast, whack it in my saw, chop off a piece of steel, job done. I can get on with the job in hand, whack it in the lathe, turn it to whatever diameter I need. So, as much as that it's cheating malarkey has reared its ugly head again, I don't care. I'm taking advantage of modern technology. I still have to have skill to silver solder, to lathe, to mill. You know what I mean? You've got to have those skills as well. And they don't come overnight. It's taken me 10 years to be able to build something with any kind of skill. 10 years. You know, it might take me 10 years to finish the engine, or it might take me 5 years because I'm building, you know, it's come on a long way in 2 years. So, you know, do we need to have that conversation? No, we don't. So anyway, enough of me waffling on about am I cheating. We're going to go and do this step now. I've left this one as it is. This is how it comes to me, laser cut. We're going to go on the other side now. I'm going to set up the tripod. I'm going to part this fret as it is. I'm going to part it, file it, knock it together. You're going to see it from start to finish what I do with it. So if this is a lengthy video, I apologise, but you know, I want people to see from start to finish what I do with that. That is how I receive it from Ed at Model Engineers Laser. I've sent him that as a drawing. He's had it cut for me, or cut it for me, and sent it me by post. I've got that one. I've got these little ones here. These ones are for the driver's pedestal in the cab. I've got these wonky ones. There, look. They're for another bit of foot plating, but towards where the cab is. Some more wonky ones. And then the final wonky ones, those ones. And you can see, I'll say when they're wonkies because they've got this. This is going to be on a slope. So that one is actually sloping that way in the engine. Or under the foot plate. So anyway, let's go off in the other side and we'll get actually some work done. Now I've waffled on about laser cutting. Let's go in there. Right then. So I hope you can hear this all right. See these parts here that I'm pressing out? I hope you can see this all right. We're not going to need these bits. It's what the laser cutter has left behind. You can see where it started there, look, and gone in, and then well, it started there, come out to the edge and whiz round. I don't need those bits. So what I do is just push them with a screwdriver. We'll push them enough so you can get them up, snap them off. And then what you're going to do with all these, once you've snapped them off, chuck them straight in your scrap tin, because I haven't got an iron foundry in my workshop, so they'll go off now to keep my scrap man happy. That's what they're going for. So I'll get rid of those, get them into the bin. Right, starts with me to go on. Trap this in the vise like so. Get your extremely oversized hacksaw for 1.5mm steel. Hang on to the other end because it's going to bend as it cuts. Cut through that top end. Cut through the bottom one. And you've got that. So you can see the two tabs are there. I've cut it off. There's a little burr on the end of there and the end of there. That's going to get filed off. And then we've got that piece. Yeah, you can see that. It's got two tips where I've just snipped that off. Put that in there. Run it with a file. Just take them down a little bit. Get them a bit closer to the actual finished steel. And I'll get a finer file just to run them off. Tickle that side like that. So it's not sharp anymore. That's done ready. There we are. Put that to one side. Now, same here. Trap it in like so. There's two things I can do here. I can do those two, file those two tabs up ready. And I can start hacksawing that off down there. All in one go. So get these ones a bit closer first. That's it. Swap files again. Now what I'm going to do at this stage, lift that up a little bit. What I'm going to do at this stage is just get, sorry if I just kicked the camera, I don't think I did, but if I did, sorry about that. Just going to get this smaller file, it's got no teeth on this edge here. I'm going to go in that, next to that tab, and I'm pressing against the end of that tab, and then going at the end of this tab and pushing it that way. And what I'm doing, I'm not shortening the tab as such, but I am. What I'm doing is taking the sharp edges where the laser cutter's been, just taking them off a little bit. Just going to run that there and there for now. Not going to do any more with that just at the minute. And you'll see why in a second. So I'm going to cut this tab up here. This enough of that top there. Take it out, flip it over, because you see how it's parted there. It's made a bigger gap than it is here. And it's tried to bend it as it parted company. That's why I say keep hold of it when you do the cut. If like that, you saw me drag the saw back over it, and that's because the edge where the laser's been has hardened it. So I'm just starting it off for the saw to get a bite, and I can go at it normally. Wallop it off like so. Put that there. Little pip there from the fret. Cut that off because it saves me filing so much of it then. Now, put that in like so. Trap it again. Coarse file, flat edge. All those tabs. Now I know someone's going to scoff and go, oh, your bloody filing technique, blah, 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 blah. You should be doing this because you're blunting your files. You should only do it, cut it one way with your file. I just want to point out, this file I'm using is older than me. It's not blunt yet, and I've been using it for 10 years. So I've changed files to a finer one just to take those edges off. What I'm going to do is undo that, run up that edge like that, turn it round, run up that edge. And all I'm doing is getting rid of where the laser's been. If you feel a bit of steel that's been laser cut, it'll have sharp edges, very sharp edges in some cases. All you're doing is just getting rid of all that proper sharp edging. Run your fingers on it. If it feels sharp, you know you haven't done a good job. So this one, put that to one side, put this one in. Just going to stay on this fine file, set the tops of them off. I don't need to because these slots that I'm filing right now, the tops of the slots, is not needed. It's the top of the slot. So the steel is going to sit, the upright's going to sit along this edge, and that's going to get finished off. I go at it with a grinder. Bit barbaric, I know, for 1.5 steel, but I don't need them. So that's why I do why I got it with a grinder. It takes a lot of meat off it dead fast. So this can only fit one way. Can only fit in there like that. You can see it already almost fits now. Now I leave it a tight fit on purpose. You might think, well, what the hell are you doing that for? You can just do it. Because if it's a tight fit and I have to give it a tap with the hammer like that, when I come to flux this up, if that is flapping in the breeze, yeah, because it's nice and tight, there's no gap or anything. If I flux this up and everything and that's flapping in the breeze, when I go to solder that joint in there, that can tip over and it won't keep a right angle in here. So what I'm doing, making it a nice snug fit, and it is a proper, you know, I can't pull it apart. It's a proper snug fit. Yeah, it'll allow it to kind of keep its shape when it's getting soldered together, because I don't iron wire this, I just leave it as it is. If it slightly drops, slightly moves out of alignment, I can tweak it to a certain extent after it's soldered. But to be fair, touch wood, any bit of wood, these, they don't go out of shape at all when they're getting soldered together. They hold their shape completely. So this one goes on the end. And these are handed. That's the wrong way up, it goes that way up. These are handed, so that's a snug fit as well. And I'll tap that home when I've fluxed it up. So what I'm going to do now is I'm going to get some flux made up. Flux all this, emery paper it and everything. Flux it all up, we'll get it soldered together. So I'm just going to pause the camera for a second while I go and get my flux because I've left it somewhere else in the workshop. So bear with me. Right, just show you this if I can. Just mixed up a bit more. And I've got it to the consistency of toothpaste. Now, the best way I can describe this toothpaste, I've mixed it more like Aquafresh than Colgate because that's how the consistency I prefer it. So, emerying up the edges. Like so. I'm just doing one edge, or one side should I say, because that's the side I need it to be. I haven't done the other side. That's it, like so. Put that to one side because I'm done with that. This is the same. I'm just doing it in the hands as opposed to on the vise. Give it a run with the emery paper, put it to one side. Same with this. All the way down one edge, across the end because the end has got that upright against it. Like so. So that's it. Now, before I go gung-ho putting it all together, make sure I know which bit's which. Move 1 or 2 things off here. Put the flux at the back so I can reach it easier. But you can still see it without me getting my arms in the way. I can get my arms in the way, so I apologise for that. Get somewhere else. So, see this? Having it along the top, all the way along the top like that. And then I'm dragging the brush on that face where I've emeried. All the way along the top and on that edge. You'll see in a minute why I'm doing that edge. Dollop in there if I can. That's it. I want the dollop in that corner because I want a good run in that corner. All the way along that edge. Now, I'm going to put this one in first, and the emery papered side in. Make sure I get it the right way up before I press it together. It's right there. Now, I'm going to trap it there, like that. Get my little toffee hammer. Tap that out. Grab hold of it. It's all up in the corner. Yeah, the flux is still where I need it to be. So this one goes on. It's going to overlap the two. So that top edge there, obviously is going to want a bit of solder in it as well. So put a bit on there. Yeah, you can touch up anywhere that might have lost a bit. Just holding together enough. Let me just trap it in the vise again. like so. Tap it out. See that? Flux all in the corners where I want it. So now I'm going to cut some silver solder to go in those gaps. I did have an offcut, but I can't seem to find it, so we're going to go for a fresh bit. This is 0.75 wire. Now I think I've said about this before, about what I use. I don't change temperatures, even with that big complex drag box that I did for the engine. I don't change the temperature of solder no matter what I'm doing. I've always done the same temperature. The wire diameter might change, but I've always just bought silver flow flux with silver flow silver solder. So I want a piece for in there. Just going to nip a bit off. There. Plonk that, straighten that gap. Using the nose of my snippers to push it into the solder, like so. Then I want another piece along the back of there, that yay long, snip a bit off, plonk it in the solder, push it up to the back. And then the last little bit, little tiny snip bit for in there, in that top corner. Being careful not to jettison it across your workshop, because it will try to as soon as you snip it. You don't want to do that. I'm just going to plonk it in that corner, in the solder. That's it. So that's all now ready for heat. So we'll cut to that bit now. Bear with me, we'll get the blowtorch on the go. Okay, we're in the, got it propped up there as you can see. Got the blowtorch ready. Get the gas on. Just going to start to warm it through. You'll see it all bubble up. The solder trying to jump about, or it is jumping about. It's heating it now. See the colour change on the actual steel. We'll start at this back end. See the solder running, coming off into the joint. I'm just going to follow it along now. What I'm using that corner, one up the face, past it. That's it done. Now, I'll point at it with a file. You can see it's gone up that joint there, it's gone up the back here, and along that joint there. So it's done all the bits I need it to do. So what I'm going to do now, I'm going to go and drop that in pickle, and then we'll talk about it afterwards. Right, so that's the start and finish of that. Obviously it's in pickle now, and I'll leave it in there for 24 hours or so. I'll probably get asked a question, so I'll explain it now. The tabs and slots scenario. So I'll use one of these wonky ones to show you. I do the tabs and slots dead to size. And I always, when I'm drawing stuff, I always do it in either 1/4 inch or 1/2 inch long or 1 inch long or whatever. I round it up. I don't bugger about with small denominations. So if it's a 1/4 length tab, it's a 1/4 slot that I'm doing. And then obviously allowing for the thickness of material. So if it's 1mm thick, it's 0.039. If it's 1.5, it's 0.059. And I do the tabs dead to size. As you saw earlier, tickling it with a file, that's got a bit of oil on it from when it comes from the laser cutters. Tickling it with a file, I'm taking off the sharp edges and allowing it to squeeze together. As I said in the video, I don't want it a flappy flap. I don't want it flapping about in the breeze, because I'm not, these foot plate supports, I'm not iron winding them together, not like I did with some other bits of the engine stretchers. And you could see in the videos that I was putting iron wire around to keep it upright and everything like that. Like that long stretcher, in the longitudinal stretcher in the frames, it's a long length of steel. I knew it was going to try and bow. If it tried to bow, it would pop the tabs open, and I'd get a gap, and that stretcher, I didn't want a gap. So the vertical stretcher that it's bolted to, that was the same. So I have to iron wire everything together to stop the steel from trying to warp out of shape. Whereas those foot plate supports, I don't know if they're just not susceptible to it happening, but with it being a real nice tight fit together, I managed to get the actual solder to run quick enough. I get the steel up to temperature quick enough with the size of torch nozzle, and get the job done as quick as I can. I know this has been a bit of a lengthy video, which I do apologise for, but I wanted to show you that start to finish process. I'll probably do in the next video, like I said at the start of it, or when I was filing everything up, I go at it. I go at the finished article to get the rest of the slot away, the material away off the slot. I go at it with a flap disc in the grinder. I don't go right down to the steel that I want left behind. I go just above it and then finish it with a file. I don't just go straight in with a flap disc and leave proper lines and marks in it. I get it down as close as I can with a flap disc. I use a flap disc because it gets rid of lots of material very, very fast. Flap disc it away. I'll show you that in the next video, because me describing it obviously isn't going to do it any justice, and it's going to sound like I'm going to make a right hash of it. Obviously people that have seen it know I don't make a hash of it, but so I'll do that in the next video. These ones that are, I call them wonky ones, they're not really wonky at all. These ones, you'll notice as well, there's no holes for the or no tabs or slots or anything for the top piece. That's because this top piece is going to be bent over, but it has to be bent over to make it horizontal when it's bolted to the engine. So I've left bending allowance on that top bit, and I'm going to bend it after it's soldered. So that could be another video for those, just so you get an idea of what I'm actually doing. I've got more parts on order with Ed for bits to go with those foot plate supports. I'm doing all those foot plate supports just because it's kind of an easy thing. it gives me something to look at. Plus as well is I'm still measuring up for the horn guides for the engine, but I'm not going to do, once I've done these bits for the footplate, I'm going to come away from the engine. The drag box will be in, and I can come away from the engine because I'm going to have to split the frames down soon for that to do the horn guides and those bits. But there's also some spotted holes on the frames that I need to drill through, and there's a lot to go on that. But what I'm going to do is go back onto the tender, get some more brass cut and start doing the tank top. But there's still some drawing to do on that, and then I've got some machining to do for the keep plates that they were literally the day before the show, had all the holes put in so that the wheel sets didn't drop out of the tender frames. But some machining to do on that with a cutter. It's got like a flute in them that needs cutting into them. But the only thing is, my DRO on my milling machine that does the height has decided to pack in work, and I need to get a new one for it, or try and fix the one that's on there before I do that, because obviously I need to get that slot dead in the right place, so I can't really do that at the minute. So I'll leave it there for tonight, or for this time round. Hopefully it won't be as long, although I know that May is going to be a busy month for me for taxi work. So I'll try not to leave it 2 weeks till my next video, but if it is, if it does drop on a little bit, I apologise now. As I said, I get out here as and when I can, and if work gets in the way, it gets in the way, unfortunately. But I will leave you with one thing, and someone might have seen it. I posted it in a couple of groups yesterday. I've already started planning, and it is in the planning stages, the next engine build, which is going to be an London and North Western Railway G2 080 in 7.25. People nicknamed them Super Ds, but they were never known as that when it comes to finding the drawings. I had some brilliant comments about the engine on the actual Facebook post, saying how rare it's going to be as an engine to see in 7.25. I think there's quite a few of them, or a couple of them, knocking about in 5-inch gauge. But I'm going to do a 7.25 one, probably not as in depth detail wise as this class 2, but certainly I'm going to put quite a bit of detail in it because of what it is, and if it's a rare looking engine, it's worth putting a bit of extra detail in it. But yeah, I've already been sent a list of all the drawings of what I need to order from the National Railway Museum, so that's quite handy, because if that takes months for them to sort out, then so be it. I've got lots to do on this class 2 before I even start cutting steel for that engine. But it's an engine that's always been up in the old brain box of one that I'd like to do besides the class 2, so that'll be a good video series. Hopefully I won't be too old and long in the tooth to do it. We shall see. Anyway, thanks, and I'll see you on the next video. Don't forget to like, subscribe, share, and tell your friends and your mothers and your uncles and your brothers and all that lot. See you soon.